So today is last day, and I'm very much grateful to all of you who are with me till this full week, or I think more than this full week. Okay. So today we will do small things, and one major thing, that is ROC. And in ROC we will do sensitivity, specificity, something. So we do how to give coding and decoding to quantitative variable like age, systolic BP, MI, BMI, creatinine, etc. Because yesterday it was left. And how to select cases in SPSS. We have learned how to split cases, how to split groups, but today I will demo how to select cases in SPSS, particular cases, okay? And how to make bar chart, box plot, pie chart in SPSS. Although we have made box plot in SPSS, but I'll give redemo on this. Then how to make table in Word file. It is very essential. Okay, because we are doing analysis in SPSS and we are getting tables in SPSS, but these tables are not like in appropriate format to present in our research paper or in our thesis. Okay, so how to make table in Word file using analysis in SPSS. So we do analysis in SPSS, then we make table in Word file. Then ROC curve, it is called receiver operating characteristic curve analysis, or area under curve analysis in SPSS. In many health research nowadays, it is we have to present our data in the form of ROC curve, and we have to calculate sensitivity, specificity, negative predictive value, positive predictive value, and their 95% confidence interval. So what do you mean by ROC? ROC, using this ROC, we get cut off of any test. In this test, we have quantitative variable and we get cutoff. So that cutoff, beyond this cutoff, we can say the test is positive, and below this cutoff, we can say test is negative. For example, we have HIV kit. For example, we have blood sugar glucometer. So in glucometer, I can say we assess, okay, we assess blood sugar of 100 patients, and on the basis of this blood sugar in patients, there are some diabetes patients and there are some normal patients, no diabetic patients, okay, normal, other disease, not diabetic patients. So when we do blood sugar, and blood sugar will come like 120, 80, okay, I can say 110, 70, 76, something value we will get in blood sugar, okay, when we do blood sugar. So there, using this ROC, we will get a cutoff of blood sugar, and when we after that we can say if this blood sugar is more than this, then it is most likely like that patient is having diabetes, and below this blood sugar the patient may not have diabetes. So it is ROC curve. We will do using this ROC, or area under curve. So we can understand it. There is one quantitative variable and there is one grouping variable. Grouping variable in the form of yes and no. Diabetes yes, diabetes no. TB yes, TB no, and any other disease. Okay, and we have one quantitative variable. For example, BP, so it means hypertension yes or hypertension no. If there is a blood sugar, diabetes yes and diabetes no. So one quantitative variable and one categorical binary variable. Okay, dichotomous variable. Then we get cut off that this quantitative variable, and we calculate sensitivity, specificity, negative predictive, positive predictive value, and their 95% confidence interval. So how? So ROC curve, first of all, introduction. So it is a receiver operating characteristic curve. ROC curve, or ROC curve is a graphical plot that illustrate the diagnostic ability of a outcome. That is a present or absent of disease, Yes, hypertension, yes, hypertension, no, diabetes, yes, diabetes, no. This method was developed for operator of military radar receivers, which is why it is so named receiver operating characteristic curve. The history of ROC curve. The ROC curve developed by electric engineers and radar engineers and was first used during the World War II for the analysis of radar signals for detecting enemy objects in battlefield. Following the attack on Pearl Harbor in 1941, the United States Army began new research to increase the prediction of correctly detected Japanese aircraft, that is a disease, it is an enemy craft, okay, and from their radar signals, that is a test. For these purposes, they measured the ability of a radar receiver operator to make these important distinctions or decisions, which was called the receiver operating characteristics. So understand ROC curve. The ROC curve is treated by plotting graphical plot. There is a graphical plot, the true positive rate, TPR, against the false positive rate, that is a FPR, at various threshold setting or cutoff. The true positive rate is also known as sensitivity, and the false positive rate is also known as 1 minus specificity. Please remember this. ROC analysis is related in a direct and natural way to cost and benefit analysis of diagnostic decision making, whether the diagnosis of this test is positive or negative. We have to assess sensitivity and specificity, and when we assess specificity, we have to calculate false positive rate, that is 1 minus specificity. So in this picture, you can see this is a radar antenna, and this is antenna beam width. You can say this is a gray, okay, gray color, and this is a target. This is an enemy, okay. This is enemy. This is a disease or enemy, and there is beam, and when these beams, I can say that these are the echo pulse from target, okay. So when the beams are stuck on this, struck by these target, so these beams will come back to this radar, and this radar interpret that this target is our own or enemy target, okay, or own aircraft or enemy aircraft, okay. So this is beautiful table, you can say. This is a aircraft code A1, B2, C3, like that. There are 10 aircraft. Detection by radar signal US is on craft, okay. For example, this radar signal detected as A1 as a on craft. In reality, it is on craft. It means it is a US craft, okay. So it is result is true. And whether B2, this B2 is detected by this radar signal as enemy craft, but in reality, it is not enemy, it is US craft, own craft. So it result is false. In C3, it is detected as enemy craft, okay, by radar signal, okay. But in reality, it is also enemy. So result is true. So we can find out according to this. For example, J10, we can see is on craft detected by this radar signal, okay. And in reality, it is on craft. So it is a true. Result is true, okay. So we can make this 2 by 2 table using this detection of radar signal. Okay, these are the 10 aircraft. So we can see here detection by radar and in a reality. Okay, so detection by radar is on and is enemy, and in reality is on or enemy. So we can see here there are 4 aircraft, okay, 1, 2, aircraft 1, aircraft 6, aircraft 8, or aircraft 10. So these are detected, these are detected by radar signal as on craft. In reality, these are on craft, so it is a true. So it is called true positive. Like that, like by radar, it is detected as on aircraft, but in reality, there is one enemy aircraft, and we can say that is in white color. That is D4. Okay, so detected as an as on aircraft, but in reality it is enemy, so it is a false detected. We can say it is a false positive, whether it is a negative, enemy is negative. Okay, so it is and detected by the aircraft as an on aircraft, on aircraft as a false sorry positive, so it is detected as a false positive. For example, is enemy detected by radar signal, but in reality, like these are two are on aircraft, so these are detected as the false negative. And by detection by radar signal as enemy, there are three, and in reality three are like enemy aircraft. You can see in like in yellow color, so these are the true negative results. So this is this 2 by 2 table created from this table you can see here. Okay, so this is now we can understand about sensitivity and specificity. So what do you mean by sensitivity? Sensitivity is probability that a test result will be positive, probability that a test result will be positive when the disease is present. What we want? We want this like sugar machine, okay, or blood sugar test. In diabetic patient, the value will come high, and non-diabetic patient, the sugar value will come low. We want this. So this is a sensitivity. Probability that a test result will be positive when the disease is present. It is a true positive rate. And what do you mean by specificity? Probability that a test result will be negative when the disease is not present. If there is no disease, it means sugar. If there is no diabetes, it means sugar level must be low. That is in blood sugar must be low level. It is called specificity. Okay, so you can see here true. What do you mean by true positive or sensitivity? It is true positive. So how many are true positive? You can say there are 4 true positive, and this is given in A cell number A. Okay, this is true positive. This is formula or to calculate true sensitivity. Okay, or true positive rate. This is true positive divided by true positive plus false negative. You have to remember this is formula. Okay, so this is true positive divided by true positive plus false negative. Okay, you can remember like that. In negative there is a n, and also in sensitive there is a n. Whereas in specificity there is p. So we can remember according to this. So sensitivity is true positive divided by true positive plus false negative. Okay, so how much true positive? You can say here in this A yet 4 true positive, and true positive is 4 plus 2 false negative. Where is false negative? In C, you can see in C cell there is a 2 false negative. So this is 4 divided by 6, 0.667, and when we multiply is by 100, it is coming 66.7%. That is a true positive rate of this radar system. It means true positive means if the on radar, okay, then they detected, okay, it is a on radar. That is a chance of only 66.7%. Then what about true negative rate? So true negative is a specificity. You can remember this specificity. So true negative is like true negative means true negative divided by true negative plus false positive. Here what will come? P. P means positive. And in specificity there is a P. So you can put P and P. You can remember this P. So false positive. So true negative is here in the, like you can see in this table 3, and true negative is 1. You can see here, and true negative then divided by like true negative 3, and false positive, sorry, true negative is 3, true negative plus false positive. So you can see it, true negative is also 3 here, you can see here. And what about false positive? False positive only given 1. You can see in B cell 1. So it is 3 by 4, it is coming 0.75, that is 75%. If there is no any like no own aircraft, so this radar will detect 75% the chance that it is not on aircraft, it is enemy aircraft. Okay, so here false positive rate here 1 minus specificity, that is 1 minus 0.75, that is 0.25, and it is coming only 25%. So false positive rate must be low and sensitivity must be high for a good test. Always remember this. So in military and in medicine, we can see, okay, we can compare this condition in military and this condition in medicine. So please look at this. Here, by detection by radar is on aircraft, is enemy aircraft, positive and negative. When we take in medicine, so it is a detection by a test A. For example, test A, that is a diabetic test, that is a hypertension, like BP test, any other test, or like for HIV test, ELISA test, okay, we can, or hepatitis B, hepatitis C test, we can see. So it is detected by positive, that is plus, and negative, that is a, maybe there is positive test, that is a negative test. Disease by, for example, by biopsy is a gold standard test. Okay, so it is disease present or disease absent. So we can put all these things similar to here, and this is, we can see it is using in earlier in military, but nowadays in medicine. With this example we can understand. So in reality, in disease there is a gold standard test, so we have to assume one test as a gold standard, and number 2 test that is not gold standard. So, and we have to assess sensitivity and specificity of another test. So one is gold standard, another is we have to assess sensitivity and specificity of that test. In example, test A, for test A we have to assess sensitivity and specificity. So can we get its sensitivity and specificity? Obviously we can get. If we get in military sensitivity and specificity, then we can get sensitivity and specificity in medicine also. It's very easy. So implication of ROC curve, with this popularity of it, it was soon introduced to psychology, medicine, radiology, biometric, forecasting of natural hazards, okay, cyclones, meteorology, model performance assessment, and other areas for many decades, and it is increasing used in data research also. In medicine, malaria test, dengue test, HIV test, swine flu test, corona test, TB test, etc. Positive and negative result depend on the ROC curve analysis of their test kits. So we are using nowadays this. So how to interpret AUC or ROC curve? In general, area under curve or ROC curve 0.5 suggest no discrimination. Okay, if we get area under curve 0.5, it means there is a no discrimination. We cannot say it is positive or negative test. Ability to diagnose patients with and without the disease or condition based on the test. 0.7 to 0.8, it is considered acceptable. 0.8 to 0.9, it is considered excellent. And more than 0.9, it is outstanding. Higher the area under curve, better the model is at predicting 0 as 0 and 1 as 1. 0 as 0 means negative is negative. 1 as 1 means positive as a positive. And we want this. In reality, we want this. Negative patient, negative, positive patient, positive, detected by that test. By analogy, higher the AUC, better the model is in distinguishing between patient with disease and with no disease. So with the help of this AUC, we can say the patient is positive or negative for that particular test. The ROC curve is plotted with the TPR, true positive rate, against the false positive rate. TPR, that is a true positive rate, is on y-axis, and false positive rate, that is 1 minus specificity, is on the x-axis. Okay, So you can see here, this is a ROC curve. And this is a false positive rate or 1 minus specificity. This is a true positive rate or sensitivity. And you can see this is dotted line, dot, red color line. It is area under curve of 0.5. So above this and below this, we can see the test is better or worse, we can identify. So you can see here, there is a ROC curve for test A, ROC curve for test C. You can see like that. So a area under curve of A is less compared to C, because perfect, when we get perfect area under curve, then we get this blue line. You can say this blue line like this, okay, here. And you can see when we like do area under curve, you can see here the blue line will get like this. So it is a like area under curve is very high. So you can see here, this is like one line is from here to here. You can see there is a one like I think this is a white line. You can see here, this is a 0.5 area under curve, and these are multiple area under curve for multiple tests. And which test is better area under curve? This is green. Okay, this green line is for better area under curve compared to this blue, red, pink, and yellow. So when we get area under curve like this, it is a very good or perfect area under curve. Okay. Now box and whisker plot. So we have to understand a box and whisker plot, also called a. So this is all about area under curve, and we will have demo on this. So a box and whisker plot, also called a box plot, which shows the 5-number summary of a data set, that is minimum. This is minimum of, okay, you can see minimum. Lower quartile, this is Q1, it is called lower quartile or 25th percentile. This is median, this is dark line between this is a median. This is Q2 or middle quartile, and then this is called upper quartile or Q3. Okay, you can see here, and this is maximum here, and these are the whiskers. So this is box and this is whisker. Okay, so it is called box and whisker plot, and this is Q1 minus Q3, it is called interquartile range. So this range of box is called interquartile range, you can see. So we can see here in box and whisker plot, there are some outliers. You can see there are some outliers. And what is these outlier? This is minimum, or you can say this is last point of whisker, okay, minimum. And if we get data according to this date, Q1 minus 1.5 multiplied by IQR, if some data or points beyond this limit, Q1 means first quartile, this is a first quartile, minus 1.5 multiplied by interquartile range. So if any point is beyond this, then these are called outliers. These are the outlier of below the minimum. And there are some outlier of above the maximum. We can say we can get Q3 plus 1.5 multiplied by IQR. Q3 plus 1.5 multiplied by IQR. So when we get IQR, when we have Q3, we have to like multiply this IQR by 1.5, and we have to add with Q3. And if some points are beyond these, so these are called outliers. Okay. So there are two types of outlier, extreme outlier or mild outlier. So for extreme outlier are data point that are more extreme than. So for extreme outlier, you can say we have to multiply by 3. And for mild outlier, we have to multiply by 1.5. So you have to remember this. For extreme outlier, they are presented as star or asterisk star, you can see. And mild outlier, they are presented as a point. Okay, so when we form a box plot, dry box plot, then you can box and whisker plot, then you can see. It means star, if you get star, these are the outliers, and star means extreme outlier. And you can, when you got point, so it means these are the mild outliers. Okay. So you can see in this picture, so these are box plot, test A. I'll give demo on this. So this is middle is your median, and this is whiskers. You can see here, this is first quartile, okay, and this is third quartile. A range between this to this is called IQR. So what is first quartile? First quartile, you can see 4. And what is third quartile? You can see 6. So what is IQR? 6 minus 2, that is 2. IQR is 2. And this is a whiskers. And this is dot point. Okay, you can say this is dot point. So what do you mean by it is a mild outlier? So what we have to do? We have to calculate this Q1 minus 1.5 multiplied by IQR. So here Q1 is 4. You can say this is 4, and our minus 1.5. And what about IQR? IQR is 2. So 4 minus 1.5 multiplied by 2. So 1.5, that is, and multiplied by 2, that is 3. So 4 minus 3, that is 1. So this point is beyond this 1. This is 1. Okay, this is 1. You can say this is 1. Here, this is 1. So this point is beyond this 1 because it is on 0. So it is called outlier. So you have to do according to this. Okay, you can see in this picture, there is no whisker. Only there is no whisker, only Q3, and on this Q3 you can see there is some line. So like Q3 and like whisker is same in this thing. Okay, maximum value and Q3 both are same in this box plot. So you can see there are some like dot plot, and there are some dots, and there are some star, and these are 120, 123, 131, 137. What are these? Are the serial number of that patient. We can easily identify of these. Okay, which patient have this I can say the 141 of serial number of patient has this value in benign group, has this test value of this 9. So we can easily identify this. And this is called box and whisker plot. And in this box and whisker plot, you can see there is no Q1. Median and Q1 are same. You can see here, median and Q1 are same because this dark line on Q1. And this in this malignant case, you can see Q3 and median are same because this dark line on Q3. So this is we can interpret according to this. So let's have fun with this. Okay. Okay. So we can have data sheet. Okay, this is okay. So I will take this, not this. Okay, this is today's data set. So you can remember this. This is a test A. This is test B values. This is a quantitative values you can see here. These are the quantitative value of how many patients? 160 patients you can see. This is a test A and this is test B. Okay. And this is a biopsy report. So biopsy report is a gold standard. Okay. Negative, negative, positive, positive. That is a gold standard. So in biopsy report, we can see this is a benign, this is malignant. In biopsy report, it is malignant means malignant. Benign means benign. This is a gold standard. So we have to find out the cutoff point of test A and test B on the basis of this biopsy report. Okay, using this ROC curve. In this case, we can use ROC curve to find out cutoff, sensitivity, and specificity. And I have coded this as an outcome. I have given code benign to 0, malignant to 1, and then you can see here intermediate. Sometimes in biopsy report, we will get result as an intermediate. I have given 2. But remember this, I have said you that for ROC curve, we have only positive and negative, not intermediate. So what I have to do, either I have to remove this intermediate patient from my analysis. So I can remove, how remove? I use this outcome because I can use this outcome. I cannot use this biopsy report like this. It is a string variable. So I have to like use this coding 0 and 1 variable. But here this is 2. So how can I do? I can remove all 2 here, then I can perform my analysis. Otherwise, I can select cassette in SPSS. I can select 0 and 1 only, and I can remove or omit 2. That is an intermediate. So how can I select? I'm going to demo you. Please see carefully. So where I have to click? I have to click on data. I have to click on data. And in data, you can see this is a split file, and this below this split file, there is a select cases. I think in SPSS, this is also here. In data, split file, and below split file, this is a select cases. So please click on select cases. This window will open, okay? And what I have to do, I have to click this if condition is satisfied. This is a default window, okay, dialog box. So I have to click here if condition is satisfied. So I have to click here. Then I have to click if. Okay, first I have to click if condition is satisfied here. Then I have to click if. This window will come, okay. So what I have to select? I have to select from outcome 0 and 1. So what I have to do? I have to click on outcome. Which variable I have to select cassette from that variable? I have to click on that variable, and then I have to bring this variable from this to this. So please click here. It will come here. You can see it came here, okay, outcome. Then I have to click, I have to select 0. So outcome is equal to 0. I have given coded equal to 0. I can type, okay, and then I can write down or, okay, or outcome is equal to 1. So you can see this, there are, you can see this is like some key you can find out here. So this is for and, this is for is equal to, this is multiply, minus, plus, less than, greater than, and this is for or, okay, or. It is not for and is here, or. So you have to click this, is this, okay? You have to click this. It means outcome 0 or, and again I have to click outcome and then bring this outcome here and is equal to 1. So what I have selected? I have selected outcome 0 or outcome 1. Whether the patients with outcome 0 or outcome 1, I will select. Okay. So I have to click continue. Then click OK. Okay. So what you can see in your data sheet, please see your data sheet. The outcome number 2, you can see here 2 intermediate, and you can see here by serial number, there is SPSS serial number. These are omitted, these are crossed. So these, the patients with outcome number 2 or intermediate patients will not be included in the your analysis. You can see cross. You can see there are 2 or more cross. So these are the 2. So these are omitted. These will be omitted from SPSS analysis. This is how to select cases. Okay. So now I will go for ROC curve. So what I have to do? I have to click analysis here. Okay. I have to click analysis. And in analysis, it is very famous button you can see. And in analysis, you can see there is ROC curve. There is ROC curve. Okay. So you have to click this ROC curve. So this will come, this dialog box will come, ROC curve. In test variable or in state variable, what you have to do? So in test variable, you have to include the quantitative variable. Okay. So that is, I will include this test A, because in test A variable has quantitative variable. So I have to click this from here to here in test variable. In state variable, what I have to do? I have to include outcome. Okay. I have to include outcome. This is present, this is absent. Yes and no, I have to include in state variable. Okay. Then value of state variable. So what is positive? I have given 0 for negative and 1 for positive. 0 for benign, 1 for malignant. Okay. So I have to click 1 here. Then I have to click with a diagonal reference line, with the standard error and confidence interval, the coordinate point of ROC curve. So I have to click all these things. Okay. So what, and then I have to click OK. Then I will get this analysis. You can see here in outcome ROC curve, case processing summary, there are positive or 45. Positive means malignant. One, we have given 1 is malignant. So 1 is coming positive here always. And negative is 0, automatic, 109. Okay. So what about? This is ROC curve. You can see this is red line is for 0.5 ROC or area under curve. And you can see this is blue line. It is like, you can see it is a very, I think, you can see excellent ROC curve. Okay, you can see excellent ROC curve. And this is 1 minus specificity, and this is sensitivity. You have to present this figure in your like paper or thesis. And you have to present also this area under the curve. So this is area under curve is 0.937. And what I told, greater than 0.9, it is very excellent, perfect test. Okay. This is standard error of area under curve. And this is p value, asymptotic significance. It came significant, highly significant. So this test is highly significant to detect this malignancy and benign, okay, condition. And this is 95% confidence interval of area under curve. So what is AUC is 0.937, 95% confidence interval. We have to write down in bracket 0.888 to 0.987 bracket band, and we have to write down p value 0.000 or 01. So it is a highly significant. Then we have to calculate sensitivity and specificity. Okay. So for this, I will not refer this SPSS. It is, I think, I don't know about 30 version. What we will get according, I will show on another software, because in SPSS 25 or up to 28, we are just getting this table. Okay. We are getting this table. How to interpret this table? Okay, 1 minute I will give on this, how to interpret this table. So you can remember this. So you can see here, sensitivity is 1 means 100%, 0.978 means 97.8%. So you can see when the score is increasing from -1, or 1, 1.5, 2.5, then sensitivity is decreasing. Okay. And what about 1 minus specificity? It is also decreasing, but it is 1 minus specificity. But we have to calculate specificity only. So what about this specificity for 1.000? It is 100%. Okay. So what about specificity? We have to do -1. Okay. We have to subtract 1 from this. So this is 1 minus specificity. So for specificity, we have to subtract this 1. So it is 0% specificity. So what about this 0.972? We have to subtract this value from 1. So it is coming around 2.78, something like that. It is only 2.8% specificity. It is very less. So when we see here, this is coming like that. It is a 97.8% sensitivity. But what about specificity? It is 63.3. It is 1 minus specificity. So what about specificity? I think it is only 37%, something like that. You can see only around 37%. It is very less. But what you see here, it is 95.6% sensitivity. But what about specificity? You have to subtract this value from 1. So it is coming around 70%. Okay. So what about this 6.5? It is around 93% sensitivity. And what about specificity? It is coming around 87%, 86, 87%. Oh, it is very good point, because where sensitivity and specificity maximum, that point we have to include, we have to take. So test A cutoff is 6.5 or greater than 6.5. Okay. So value is we found out cutoff value as a 6.5, greater than 6.5. So if we test in another patients, in another group of patients for same disease, and if we test this test A, and if we in test we will get, if we get value, for example 8, so it means it is greater than 6.5. So we can say this test is like 93.3% sensitive hai, and it is 86.2% specific, we can say according to this. But SPSS, it is very tough to get idea about sensitivity and specificity. We have to do manual calculation. We have to do manual calculation. But in another software, okay, that is called MedCalc software. And in MedCalc software, these are coming very easy with 9, and we are not getting in SPSS 95% confidence interval of sensitivity, specificity. Okay. And in when we do ROC curve or area under curve, we have to get Jordan index also. And what is Jordan index? Jordan index is what we are getting in sensitivity and what we are getting specificity, we have to add, and this add or some value is our Jordan index. For example, in this case, sensitivity is 93.3. So we have to add 93.3, 0.933 plus specificity around 86. So we have to add 0.933 plus 0.86. Okay. Then we have to add this. We have to sum this. So it is called, the value is called that Jordan index in ROC curve or AUC curve. And we have to give this Jordan index in our paper also. So what is your Jordan index of this ROC curve? So we have to present this also. So in SPSS, like in 25 version, or I think below 30, I don't know about 30, Jordan index we are getting or not, but I will give demo on MedCalc. Okay. So we will get everything in this MedCalc. Okay. So what we have to do? We have to open this MedCalc here. So where I can like, okay, I can cross this. I don't want to save anything. Okay. I want just cross it. I don't want to save anything. No. Okay. Then I want to cross also this output. Then what I have to do, I have to do in data sheet 8, sorry, I have to remove these from outcome 2. So how many 2 I have to remove? So what I have to do, I have to click on outcome. Then I have to click right click on my pad. Then I have to click sort descending. So by doing this, all 2 will come upside. So I can remove easily. I can remove, no issue. I can remove, because in SPSS, I omitted, I ignored this. So I can remove. It means it's already omitted. Okay. No issue. So I will not include this intermediate. I will do only for malignant and for benign thing. Okay. So then I can click save. This is a save this document. I will click. Then I will cross it. Then I will open MedCalc. So I can see where is MedCalc softwares. This is MedCalc software, you can see here. Okay. Left upper corner nearby Dell, this is MedCalc. I have to open this. I have to click this. This will come. This is a MedCalc software. And I have to enter import data in this. So what I have to do, I have to click this data. This is data. You can see file, edit, view. And here you can see this is a data point. Okay. I have to click. You will get Excel sheet here. So this is a Excel sheet here. Okay. After clicking this data, then I have to import SPSS, I can import SPSS file in medcal. So it is very good thing. So I have to click a file. Then I have to click open, file and open. So please click open. Then you will get this dialog box. Okay, so where is my SPSS file? In SPSS session, I have SPSS session. I have to click this. And this is data sheet day 8. So I have to click this day 8. So this data sheet day 8 will come here, file name. Then I have to click open. Then it is saying that what you want to include. I want to include all these parameters or variables. So what I have to do, I have to click all. Okay. Then I have to click OK. So all the variable came here in this imported in a medcal. So now I will do ROC curve in medcalc, and beautiful things you will get in medcalc. So click statistics here. This is a statistics. Every software has one like analyze or statistics. In SPSS, it is analyze button, and in medcal, it is a statistics button. Okay. Then this is ROC curve, and this is ROC curve analysis. You can see here ROC curve analysis. Then you have to click this. In variable, you have to bring test variable, and in classification variable, you have to disease present or absent variable. Here, outcome variable. Okay. In variable, I have to bring test variable, quantitative variable I have to bring here. So this is a test A. In classification variable, I have to bring a outcome variable, and I have to define here. So I have to click define status. So it is already defined. I have given positive as a 1 and negative as a 0. Okay. So I have to click OK. Then what I have to do, I have to, please remember here, disease prevalence or pre-test probability of disease, I have to click this. The ratio of cases in the positive and negative group reflect the prevalence of the disease. I have to select this. Then this calculate optimum criterion value taking into account. This is a false positive, false negative, true positive, true negative. Okay. So this is default setting. This is default setting. We have to just click this button only. No need to do anything else in this. Then click OK. Then what? You will get this ROC curve, beautiful ROC curve you will get. And in here you can get AUC as a 0.937 and P value. It is very beautiful ROC curve you can get. Okay. In this medcalc also. After that, you can see here, there are positive is 45. There are malignant. Negative means benign, that is 109. And you will get this area under curve standard P value, something like that, which we got in a SPSS. You can write down from here. Then most important thing, this is Jordan index. So you can see here, Jordan index J is 0.7957. This is if you plus this and this, you will get this. Okay. You have to this is it is sensitivity 93.33% and specificity 86.27. In medcalc, no need to do any calculation, but in SPSS we have to do manually calculation. We have to do to get sensitivity and specificity, and this is association criteria. This is greater than 6, and where what we got greater than 6.5. Okay. But in value, when we see test A, there is no 6.5 value. So here it is a greater than 6. It is our greater than 6. It means 7, because in test value we are getting 7. So it is a 7 and above 7. Okay. So greater than 6 means this. Okay. So this is sensitivity and specificity. This is a Jordan index, and this is very beautiful table. You have to remember this associated criterion greater than 6. So what you have to do, you have to select this criterion on the basis of these score. If you select greater than 1, so this is sensitivity, this is specificity, this is negative, this is sensitivity, this is 95% confidence interval of sensitivity. This is specificity, this is 95% confidence interval of specificity, this is our positive likelihood ratio, this is 95% confidence interval of positive likelihood ratio, this is negative likelihood ratio, it's 95% confidence interval, this is positive predictive value, This is 95% confidence interval. This is negative predictive value. It's 95% confidence interval. Leave it this cost. No need to do because this is the high cost. Okay. One means high and this is these are the costs. So you can see here on 6, greater than 6, these are the sensitivity and specificity and their 95% confidence interval you can report in your data, in your paper, in your thesis. So this is beautiful. MedCalc software is very beautiful to calculate this ROC curve. It is very beautiful. You can save, you can copy paste it, you can report in your research paper. Okay. So this is all about sensitivity, specificity, area under curve, something like that. Then I will show how to make tables. Main thing is how to make tables in a Word file. It is very important. So this is data sheet of day 7. So for we have two groups in intervention group and control group. So we have two groups. So how can I make tables? So what we have to do in Word file. So please open Word file here on this, right click, new, and this is Microsoft Word document. So click this Microsoft Word document. Yeah. And you can say this is a result tables. Okay. So I will show how to enter in for t-test, after that chi-square test, or after that like main witness test data here. Okay, table. So click this, open this. So I know I have two groups. Okay, then when you open first time, whenever you open first time this Word file and this is opening, this cursor is blinking here. And when you want to draw tables, make tables, so please remember 2 or 3 times press enter button. 1, 2, 3. So you can give its title, table title, vagera. Otherwise, you cannot give. It will create a lot of like problems. So it is my habit. When I make table, I will enter 1 and 2 times. Only 1 and 2 times you can enter. Then what you have to do to draw table? I have to click this insert nearby this home. Left side top corner, you can see here in home, here insert. So click insert, and insert, you can see just below this insert, this is a table. So click this table. Okay, click this table and insert this table. So I have two groups. So I need at least two groups, mean two column. Then I can take 4, 5 columns. So I can select this. I can select 4 column, 5 column, 6 column, whatever. I can delete after that. So 5 column. Then what about rows? I can select rows up to this. No issue. Okay. So this is table. Please remember this. You have to click on insert. Then insert, you will have this table. And then click. Then you can select 4, 5, 6, whatever. And then you can select this. Okay. So you can do this. Then what I have to do? I know that I have two groups. So number 1 is intervention group. So what I have to write down here? Intervention group. Then I have to write down N. So N is equal to whatever. For example, 70. How many patients? Then in this third column, I have to write down control. Okay. Then what I have to do? I have to click. Then I have to N is equal to also 70. Then I can click here in 4th column. I can write down t-test value, comma, oblique, chi-square test value. Okay, value. You can correct spellings, no issue. Okay. Then if you want to write down degree of freedom, you can write down DF, means degree of freedom, and you can write down P value. You can, and you can like bring this, you can drag, you can see here my cursor. So when it is like 2 arrow, you can drag it and you can increase size and decrease size. Okay. And if you want to remove this, this column, so what you have to do, you have to click this here and then right click and delete cells. This is a delete cell option. You have to click this delete cell. then you have to click on delete entire column. I delete entire column. I don't need this column. Then click OK. These are the variable. You can say these are the variable or parameters here. So number one, variables. So what is this? Is first is age in years, and I have to write down here age in years, and I have to write down here mean plus minus SD or frequency percentage. Then median and interquartile range. There are three types of data I can present here. Mean plus minus SD, minimum maximum, frequency percentage, or median interquartile range. So what I have to do, I have to click where I have to write down mean, okay, and where is plus minus SD. So you have to go in insert, you have to click insert, and there is one button symbol on right side top. This is a symbol. So you have to click this symbol, and this is plus, you have to click this. So this will come mean plus minus SD here. Then SD means standard deviation. Oblique frequency percentage. Okay, you can write down here. And you can copy paste this also here. From here to here, you can copy paste. Okay. Then what you have to do, I have to calculate age in years. Okay, age in years, I have to calculate. Then I have to write down all the things. So from where I have to calculate, I have to go to data sheet. Okay. So what I have to do, I have to click here. And then where click analyze. Then compare means, because age is normally distributed, suppose, and this is a quantitative variable, and there are two groups. I have to use independent t-test. So I have to click this. I have to bring, this is, I have given group code here, okay? If you remember yesterday, group code, you have to bring this group code in grouping variable. And then I have to define group, and I have given 1 and 2. 1 and 2. 1 is like control and 2 is intervention. Then click continue. Then this is the age of caregiver. Suppose this is the age of caregiver or age of patient. I have to click this. Then I have to bring this here in test variable. So I have to click this. Then I have to click OK. So this is age of caregiver. Suppose it is a age of the patient. Okay. So in control group 80. Okay. I have written 70. So I have to correct it. It is a n is equal to 80. Then this is a mean and this is an SD in a control group. And what about intervention? It is mean and this is SD. So what I have to do, I have to bring this half I have to do. Okay, I have to bring. Otherwise, it is very difficult to open again and again. So what I have to do, I have to make two screens here. Then I can easily enter. This is intervention group. Okay. So this is age of, for example, patient. So mean and SD. This is the intervention group, 30.54. And where is plus minus? I can copy this plus minus from here. Okay. So I can bring here. And what about SD? SD is 7.54. Okay. It is not frequency percentage. It is mean SD. And in control group, what about 35.0? I can write down. Plus minus, I have already like copy, so I can paste it. And then what about SD? 10.5, and this is 49, so I can say 55. What about t-test value, chi-square value? And it is obviously t-test, I have to write down t-test value. But I have to remember what I have told. It is Leven's test of equalative variance is less than 0.05, then I have to take equal variance, not assumed p-value. But both are significant. You can take as you want. If you take 0.002, it is also significant, highly significant. If you take 0.003, it is also coming highly significant. So you can take. So what about t value? T value is here, 3.078. And you have to write down degree of freedom in in bracket. So 158. So what about degree of freedom in t-test? N1 minus 1 plus N2 minus 1. So what about N1 and N2 are similar, 80. So 80 minus 1 plus 80 minus 1. So 80 minus 1, that is 79, plus 80 minus 1, that is a 79. 79 plus 79, you will get 158. So it's okay, very good. And what about p-value? So this is p-value of, you can find out p-value of t-test. It is coming 0.003. So I can make table according to this. Then I will want to like a table of chi-square. So what I have to do, I have to apply chi-square, then I can make table of this chi-square. So what I have to do, I have to click analyze, then descriptive, then cross step, okay. Then what I have to do, I have, this is my group code, I have to bring in column and this history of previous stroke, yes and no format. So I will do this, okay. I will bring in a row. So always like group, you have to bring in column, and then other things, categorical variable, you have to bring in a row. Then what I have to do, I have to click on exact. If I remember, it's my habit. Then chi-square. Then what I have to do, cells in percentage column, okay. Percentage in columns, then continue, then okay. Then I got this. So what I have to do, I have to write down history of previous illness. So please write down, I don't have time, history of previous stroke, suppose, okay, this is a previous stroke or TIA. So in this case, if we like found according to this yes and no format data, yes and no, so you have to write down only yes data here, yes result, not, no need to write down no result. So what is yes? 1 is yes, 0 is no. So what I have to do, in intervention there are 8 patients, so I have to write down 8, and in bracket I have to write down percentage, that is a 10%, okay. And in control I have 20. In history of previous stroke or TIA, how many patients? This is 1 is present, 0 is absent. I have to write down only about 1. So here 20, and then in bracket I have to write down percentage 25%. Then I have to write down here, it is not t-test, it is a chi-square or Fisher exact test, and degree of freedom p-value I have to write down. So what I have to see, I have to see, oh, it is 0 cells have. First of all, you have to see 0 cells in chi-square. It is 0 cells, so you have to take Pearson chi-square value. This is value. So what you have to write down, it is 6.234, and in bracket you have to write down degree of freedom. So in chi-square, what is degree of freedom? R minus 1, okay, multiply by row minus 1 multiply by column minus 1, okay. So how many column or how many row? There are 2 column and 2 row. It is a 2 by 2 contingency table, you can see, okay. It is 2 by 2. So what? 2 minus 1 multiply by 2 minus 1. 2 minus 1, 1 multiply by 1. 1 minus 1 multiply by 1, that is a 1. So it is a degree of freedom 1. I have to write down. Then comma, and what is p-value? P-value is asymptotic significance two-sided. If there is a 0 cells, I have to take this p-value two-sided. 0.013. I can write down according to this. Now last, if I have not normally distributed data, this is last. If I have not normally distributed data, then how to make median and interquartile table, okay. So for this, I have to calculate first, I have 2 groups, and suppose this time this age is, suppose this time this age of caregiver is not normally distributed. For example, it's not normally distributed. So I have to use a Mann-Whitney test. There are 2 groups. This is a quantitative variable. This quantitative variable is not normally distributed. I have to use a Mann-Whitney test instead of a t-test. Mawali kahin ka. You have to remember that. So what I have to do, I have to click analyze. Then I have to go in non-parametric. Then I have to go into legacy dialog. Then this is a 2 independent samples. So I have to click this 2 independent samples. Okay. Then I have to bring this group code in this grouping variable. I know very well. Then define group. I know that I have given 1 tab 2. I have given 1 and 2 according to control and intervention. Then click continue, and then bring this age of the caregiver into this test variable. This test type is already selected. This is a Mann-Whitney U test. Then you have to click OK. So this Mann-Whitney U test can give only p value of this. This is asymptotic significance, two-sided is only p value. And this Mann-Whitney u value, okay? So in this case, you can just write down p value. So where is my table? I can write down here p value, 0.008. And in here, I can write down m. M means this is Mann-Whitney. I can put on footnote m is equal to whatever. You can give any symbol here. Here I have given m. M means Mann-Whitney u test. I can give, okay, like this, u test. Then I need a median and IQR, and this is for age of the caregivers. This time it is a age of the caregiver. So I have to given in median and IQR. So from where I can get it? So for this, when we use Mann-Whitney u test, and in between groups, if I want to get median and IQR, so what I have to do? I have to go into data. Then in data, I have to split file. Okay, I have to split file. Then I have to click organize output by group. I have to click this. I know it's very hurry, but we don't have time. And these things I have already explained you 2, 3 times, 4 times. So I'm like making it hurry, fast. Okay, then I have to click organize by output. Then I have to click a group code, because I know I need median and IQR according to group code. So I have to click this, and I have to bring this group code into this group based on. Then I have to click OK. So I have splitted this file. Then I can get a median and IQR between groups. So from median IQR, I have to click analyze, then descriptive, then frequency. So in Mann-Whitney test, there are 3 steps. One is to get p-value of Mann-Whitney. Number 2, split file. Number 3, we have to go in descriptive and frequency, and then we have to calculate median IQR. Please remember this. Then click this. For what I have to get this? For age of caregiver. So I have to click age of caregivers. I have to bring this age of caregiver into variable view. Then what I have to do? I have to click statistics here, and here quartile. If you want to get this minimum and maximum, it's okay, but you have to, for median IQR, you have to click on quartile, then click continue. Then you not need this display frequency table. Suppose you leave it, okay, no issue. But if you leave it as such, then what happen? You can see here, you will get unnecessary these things. You not need these things, okay? So, okay, then what I have to do, I have to click this and then delete. It will, okay, it has gone, delete. So this is you can see here, this is a median and IQR in control group. This is median and IQR in intervention group. What is 25 is first quartile, 75th is third quartile, and 50th is median, second quartile. So for first, I have to write down intervention, then I can write down for control group. So for intervention, what I have to write down? There is a 29.0 bracket 25.0 dash 37.0. You have to write down median and IQR according to this. Then I have to write down for control group. So what I have to write down? 33.0 is median, bracket, open bracket, 27.0 dash. You can write down dash in place of dash TO2 also. It is gone, no issue. Okay. Then you have to write down 40.75. Then you have to bracket close. So this is you can superscript it m. So what you have to do in home, you can write down this x square. You have to select this. You have to click in home x square. This is superscript. And what is m? You have write. So how to make tables? I have like shown demo on t-test, frequency and percentage, chi-square, and then age of the caregivers. Okay, then when you practice on this, you will get more and more. Now, how to do category, because we don't have time, but I have to show you, because these are the main things for you. Now, I want to make a category of this quantitative variable. Yesterday, we have left it, okay, for age of the caregiver. I want to make category. This is a quantitative variable. but I want to make category like 20 to 30. So what is minimum and more, what is maximum? I can say here, I can, then it is right now it is splitted. So what I have to do, I have to go again data, then split file, then I have to remove this analyze all cases, do not create group. I have to click this. Now split is off. You have to click OK. Split off. Okay. Now I have to make like category of this age of the caregiver. So what I have to do, I have to click, I want to get minimum and maximum. So simple thing, I have to click this and then sort ascending. So this is 18 to 18 is minimum and 66 is maximum. I want to like bring. So I can bring 20 or less than 20, 21 to 40, and 40 to 41 to 60, and greater than 60, or might be greater than 40. Okay, greater than 40. So I want to make three categories here. Less than equal to 20, 21 to 40, and greater than 40. So how can I do this? So you have to remember this. So what you have to click this transform. Okay, here is a transform before this analyze. So click this transform. Then you have to click a record into different variable. Okay, you have to click record into different variable. We have already used this. Okay, you have to click this. So for which variable we have to make categories? For age of the caregiver. So you have to click age of the caregiver. You have to bring this age of the caregiver from this to this in input variable. Then output variable, I have to give name. So I can give name age care cat. Age care means age of the caregiver. Cat means categories in short form. Then I have to click on change here. So this will come here. Then old and new values, I have to click here. Okay. Then this is. So you have to remember this and you have to see this dialog box. Record into different variable, old and new value. So what you have to do, because I have like decided that less than equal to 20 is I have given 1. So what I have to do, I have to click this less than equal to 20. So I have to click this range lowest through value. I have to click this. Then I have to put it here 20. So it is less than equal to 20. Then I have to give in a new value. I have to give a code as a 1. Then I have to add. I have to click add. So all less than 20 or equal to 20, I have given code 1. Now 21 to 40, I have to given code 2. So what I have to do, I have to click on range, okay, for this range. So what I have to do, I have to write down here 21 to throw 40. I have to write down. You can make anything, okay, according to you. Then new value is I have to, suppose I have to give 2 values. Then I have to click add. So this is 21 to 40. I have given code 2. Then greater than 40, I have given 3 values. So what I have to do, I have to click range through highest. I have to click, and then I have to, what I have to write down, greater than 40. So I have to write down 41 here, because 41 is included in this. Otherwise, if I write down 40, it will also included in this. So I have to write down 41. So 41 and above will be included in this. So I have to give one value 3rd here. Then I have to click 8. Then I have to click continue. Then I have to click OK. Then where I will find out it at the last of this data table. So this is age category. You can find out here. Okay, and you can see here. So I have made this quantitative variable into categorical variable. Then you can give like you can decode it, values and something. I have given demo already. So you can make this age of the caregivers. Okay. Then two things, pie chart. Okay, pie chart. So how to make pie chart? So what I have to do, I have to, pie chart is for categorical variable for this. Okay, pie chart is for categorical variable. Okay, and box and whisker chart for quantitative variable. You have to remember pie chart for categorical variable, box and whisker for categorical variable, and bar chart you can make for categorical also and you for quantitative also. Okay, so I have to click analyze, sorry, graph, because this time it is like for graphs. So I have to click on graphs, then I have to click on legacy dialogues, then I have to click on pie chart. Okay, so when I click pie chart, this window will come. Summarize for group of cases, I have to click define, this will come. So it's very simple. So if I click on age care category, I want to, because it is for grouping variables. So what I have to click on define slice by here, and I have to click on, if I can, number of cases or also percentage of cases. Suppose I want to click on number, percentage of cases. And in this define slice by, I can add categorical variable. Okay. Then I click OK. Then you will get this pie chart here. You can modify it. You can double click it. Okay. You can double click it and you can modify it. This is a chart editor. You can modify it accordingly. This is button for if you want to add values here, data label. So this is button for. Okay. This is a gunpoint button. You can see here. This is a gunpoint button. You can click here. Then you can bring your data type here. It's very, you can copy paste it. It's very beautiful. And what is 1, 2, 3? These are the, you can see this is a less than equal to 20, 21 to 40 and greater than 40. Okay. This is for box and whisker plot. Okay. So I think my visible to you.
Sir, your screen is visible. You can go ahead.
Okay. Thank you. Sorry. I'm really sorry. So I have to click age caregivers. Okay. Then I have to bring this age caregiver into variable view to make box and whisker plot. Then I have to click this group code here. I want to see like box and whisker plot for age caregivers, age of the caregivers between control and intervention. Okay. Then I have to click on group code. Then I have to bring this group code into category axis. Then I have to click OK. Yes. Whatever variable, quantitative variable, you have to bring here variable. Okay. Then click OK. Then you can see here, this is a beautiful box and whisker plot you will get. This dark line is median, whiskers. There is only mild outlier. And what is it? It is a 160 number of the serial number patient. You can see here. Okay. These are the box and whisker. This is a control group. This is the intervention. If you want to change color, then what you have to do? You have to double click it. And what you have to do? You have to double click it. Again, you have to click these box. Okay. Both box already selected. But I want to change only intervention group color. Okay. Then I have to click on intervention only. Okay. Then you can see here only intervention box is selected, not this control box selected. Then I have to, this is a color. Okay. Fill and border. So I have to click on any color I can bring here. And then I have to click on apply. Okay. Then you can see here its color changed. So these are very beautiful graph you can find out. Okay. So next is bar graph. Final is bar graph. Okay. So where is you have to click. If you want to change anything in this, you have to, what you have to do? You have to double click it. And if you want to make this age underscore caregivers, age of the caregivers like this. So what you have to do? You have to double click it. You have to click it. Oh, it came like this. So what you can write down here, age of the caregivers. Age of the caregivers. Then click enter. It will come here. You can change here group code. You can make like only groups. So you can change. You have to click this. This is selected. Then again, okay. Then you can. This is groups. Then what you have to can cross it. You can copy paste it. No issue. Okay. Last bar graph. What you have to do? You have to click graph, legacy box, and this is bar graph. Okay. Then what you have to do? You have to click on simple bar, cluster bar, stacked bar, whatever you. For example, simple. So click simple and define. Okay. So these are the, so for variable category axis, what you have to do? Simple. Okay. Simple. So I want to bring this age care category here. Okay. Or what about bed sore or Kupuswami scale? Suppose Kupuswami scale. I want to make bar graph according on the basis of Kupuswami socio-economic status. So I have to bring this in category axis because I know Kupuswami is a categorical variable. So click this, then click OK. You will get a beautiful bar graph according to this. Okay, then you can make color changes here. So what you have to do, you have to double click. You have to make increase or decrease width of this. So what you have to do, you can depth and angle, start bar option, you can increase or decrease. Okay, suppose, and then apply. These are. Then if you want to add data, you can click this. You can add data here. Okay, whatever. If you want to, and then you have to again click here. If you want to change color, so if I want to color change for, then what I have to do, I have to click, I have to again click this, then only this will be selected. Then I can click any color, then click apply. So one by one you can do, and then I can change. If I want to change this color, I have to click this, then I have to click green color. You can make beautiful graph with this. Then I have to click on Kupuswami 5. I want to click this violet color. Then okay, cross. I can make this car. And if you want to write down 1, 2, 3, 4, what is it? You can write down. For example, you have to click this. You have to click 1 and 2 times here. Then you can click this. It is a upper class. Okay, it is a upper class. Then you have to click 2. Then you have to gently you have to click, it will be highlighted. Okay, then you have to click this, whatever it is, I think upper class. This is a upper middle class. This is a upper middle class. If you remember class, you have to remember these things. Then I can make this. Okay, then I can cross it. I can do anything with this. Then what I have to do, I have to save this. So this is a, for save, I have to click this. Okay, export output, then I all visible every time. Then this is a results of this is 28. Then I can make it 28. Then click OK. It will be saved in a SPSS or a Word file. Okay. Thank you very much. And I'm really very sorry. There is some problem in network. Really sorry.
Thank you, sir, for such a wonderful session.